Hello everyone. In this video, we will discuss BGP EVPN Route Type 5, which is also called IP Prefix Advertisement Route. This route type is described in RFC 9136. So friends, let's discuss why do we need route type 5 in the first place when we already have a route type 2 which optionally advertises the IP address as well. It does advertise the MAC address, but route type 2 also optionally advertise the host IP address. So why in that case we need route type 5? So as we could see in the topology, we have multiple leaves with servers or hosts behind them, and the leaves are connected to spines in a redundant manner. But we have a leaf, which is leaf 103, connected to an external router R2, which provides WAN connectivity. And depending on the topology, the remote router could have this link connected to the leaf switches either over the main interface or over sub-interfaces, and those sub-interfaces could belong to different VRFs. But again, that depends on the topology. Also, by design, when we configure BGP between a border leaf and an external router, the border leafs by default advertise all the EVPN learned routes into the eBGP domain. So as the border leaf learn the /32 host IPs along with the host max in a route type 2 advertisement, it will push those /32 prefixes towards the external router, which in our case is R2. But does an external device need to know the /32s or the host routes in our internal domain? Well, the answer to that question is no. Again, this could be down to scalability issues on the receiving device, as we know that the more prefixes that we advertise to our eBGP neighbor or BGP neighbor, the more resources it's going to consume, and it will make things complicated when it comes to troubleshooting issues. So this is where route type 5 comes into picture. So route type 5 advertises an IP prefix, which could be a /24, 25, 20, whatever the block is in our internal VXLAN domain, across an eBGP session towards an external router. So with route type 5, we could prevent /32 advertisements across the eBGP or across an external connectivity, which could be over an MPLS link or a GRE tunnel or a DCI link. And as we have already discussed, EVPN is a family member of multi-protocol BGP, and like BGP, EVPN also sends multiple kinds of messages like updates, keep alives, notifications, etc. And path attributes or prefixes are sent as an NLRI update. So as we see on the screen, when an update is sent, it is sent as an NLRI with all the BGP attributes like weight, local preference, AS path, met values, etc. So if you quickly look at the EVPN Route Type 5 packet header and its contents, the first thing it contains is the route distinguisher, which identifies the sender of this route type or of this update. And in the Cisco world, the route distinguisher takes the format of the router ID colon the VNI plus 32767, and the next field in the packet header is the Ethernet segment identifier, and its value is set to 0 if the ESI value is not used as the overlay index, and we will go over the overlay index discussion in a minute. The next value is the Ethernet tag, which is set to 0. The next field is the IP prefix length, which could be either 32 bits or 128 bits, depending whether the update is for an IPv4 or an IPv6 prefix. And then we have the IP prefix itself, which is again, which depending on the previous IP prefix length, could be IPv4 or IPv6. And then we have the gateway IP address. It is the IP address of the advertising border leaf, i.e. the device that performs or that terminates a VXLAN tunnel and then performs routing to the external WAN across the BGP session. So this is where the border leaf plays a slightly different role as compared to a typical spine device. So in case of external connectivity, the border leaf, which in our case is leaf 103, or takes part in both the control plane and data plane functionality. So it learns the prefixes from external devices, which in our case is R2, and it also is the transit router when it comes to traffic flow from the VXLAN fabric to the external domain. And coming back to the packet header, we have the MPLS label field, which usually carries the VNI of that particular VXLAN network. We also have the extended community route target, which carries the configured route target for a particular VRF. And based on the import and export values configured inside the VRF, the receiving device can accept or discard the prefix based on the import values configured at their end. So the export route target community sending end must match the import route target community at the receiving end. And then the next field is the tunnel encapsulation extended community, as the encapsulation type could be MPLS, it could be VXLAN, or it could be GRE, etc. So guys, we briefly touched upon a concept called overlay index during the course of this video. So let's have a quick discussion around what exactly is overlay index and what does it do in the context of EVPN Route Type 5. So at a very high level, the overlay index is the next hop that the ingress NVE should recurse to while sending traffic to an egress NVE. And this overlay index can be an IP address, a MAC address, or an ESI value. So as explained in the RFC, so when advertised along with an IP prefix, the overlay index requires a recursive resolution to find out the egress NVE to which the EVPN packets need to be sent. Or in general BGP terms, for a route to be valid, the next hop must be reachable. Similarly, in the terms of EVPN Route Type 5, for an IP prefix advertisement to be valid, the ingress NVE must be able to recursively resolve to the egress NVE to which the EVPN packet needs to be sent. And also, there are a few underlying requirements when it comes to using ESI or gateway IP for reachability towards the advertising border leaf. For example, if you're using the ESI field to advertise a route type 5, the receiving device of that route type 5 will also need a route type 1, which is the Ethernet auto discovery route, to get to that advertising router. And if you're using a gateway IP to advertise the route type 5, we must also advertise a route type 2 for that gateway. In other words, the receiving device must be able to resolve to that gateway IP. And if we are using the MAC address to advertise the route type 5, the extended community route target field is used to carry the MAC address of the advertising or the border leaf. And like we have done in our previous videos, we'll quickly go over a Wireshark capture of an EVPN route type 5 packet. So we can see that here in this case, the leaf 101, which is 10.0.0.101, has sent an update towards the spine, which is the 10.0.0.201 BGP peer. So if we expand the BGP update message, we see that it's sent as an NLRI, and within that NLRI, we sent it as a route type 5, and it has the route distinguisher value as we discussed. It has the ESI value, which is all zeros. Ethernet tag is all zeros. Prefix length is 24, which is again a /24 subnet. The IP address field contains the actual prefix. The gateway address is not used in this case, so it's going to use the last option, which is the MAC address. And as discussed, the MAC address is carried in the extended community field. So if we expand the extended community field for this update, so if we look at the extended community, it has the MAC address of the advertising router, and we can verify the same on the CLI with this command here, which is show BGP L2VPN EVPN Route Type 5, and the route type 5 here is for the prefix 192.168.10.0/24 as indicated here. And as this is originated by the local device, we have all zeros here. And then it also identifies the router MAC, which is listed under the extended community field. And in terms of what triggers the generation of route type 5, it is the redistribution of routes within BGP. So for example, in our case, we have an SVI for VLAN 10 on leaf 101 with the IP address 192.168.10.254, as we see on the screen. So that in itself does not really generate or does not trigger the router to advertise an EVPN Route Type 5 prefix. So what does generate the Route Type 5 prefix is the redistribution of routes within BGP. So if I do a show run section BGP, so as soon as I entered or redistributed the direct under the VRF, so again, I'm only advertising directly connected routes with a route map, wherein I'm not advertising /32s. So as soon as we configure this redistribution, the leaf switch will generate a route type 5 towards its L2 VPN, EVPN, BGP neighbors. And regarding the MAC address that we see as an overlay index, which is this bit here under the extended community field, this gets generated or this gets derived from the SVI of the interface itself of the VLAN. So in this case, as you can see, the under VLAN 10 or under SVI for VLAN 10, the MAC address is the one ending with IB08, and that's what we see as the router MAC here. And if we compare that with the same value on leaf 102, we see the router MAC here as, again, it's IB08, but the first couple of bytes is OC89. And if you check the SVI MAC, it is OC89, all zeros, and then IB08, as we see in the router MAC address field here. So friends, this was an overview of route type 5 within eBGP EVPN setup. I hope you like this video. If you do like this video, please share your feedback, comment, like, share with your friends and colleagues. And if you're new to this channel, please subscribe. Thank you very much for watching this video. Hope to see you soon.